So time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of length of time input. So suppose let's start with an example first. So suppose our running time for an algorithm is 3n plus 2. Uh, let's take an example first. So if our running time is 3n plus 2, we can versus if our running time is n square plus 4n plus 1, where n is the number of terms given to us. So which algorithm should be better for us? We'll analyze that using time complexity. Generally, during contests, we are given 1 to 2 seconds time limit to run our code. So we must write efficient code that passes this time constraint. There are three main notations for this time complexity: theta notation, big O notation, and omega notation, each representing average case, worst case, and best case time complexity. So in general, we just talk about the big O notation. You might learn the other ones in your algorithm courses if you have one. So let's start with the big O notation. So if here is the formal definition, but it might sound tricky in the beginning. That big O notation, it represents the upper bound of a function. If we have function fx, then consider function gx such that fx is less than constant multiplied by gx for all values x greater than equal to x naught for some x naught. So let's look at the example first to understand it. If we have a function 3n plus 2, so think of an function gx such that c into gn would be greater than equal to fn. So you can think of c equal to 4, so and gn equal to n. So our gn can be equal to n. So fx can be written as big O of gx. So fn is equal to big O of n. So if our running time is 3n plus 2, we can simply write it as big O of n. Since we are considering the worst case, we'll write the bigger term. We can ignore the smaller terms since when we are analyzing time complexity, we are assuming n to be very large, almost infinite. Also, so let's look at another example. Here our running time is n square plus 4n plus 1. So we can write it as fn equal to big O of n square. So since the highest order term is n square, the function will grow on the order of n square. Therefore, the function we can write it as big of n square. So whenever we are writing time complexity, we are only riddled with the highest order term, since that would scale much faster when our n grows larger. For always for time complexity analysis, we assume very large n, so the smaller terms are neglected. So if we consider these operations like int a equal to 5, b equal to 7, and d equal to a plus b plus c, these statements run in big of one time, simply defining the expressions and adding them, subtracting them. That takes big of one time. Input and output operations also take big of one time. So big O of 1 is the smallest one, which is constant. We'll have op other operations like big O of 1, big O of log n, big O of square root n, n log n square, and so on. Let's have a look at them. So simple declarations, input output operations, and addition subtraction, uh, ar- these arithmetic operations cost us big O of one time. Now, since you have already studied loops, let us now look at these examples. So here is a for loop running from 1 to n. So what would be the time complexity of this? Assuming this is constant, so Let me write it here. So running time for our inner loop, this would be some constant operations. So we represent constant by big O of 1. So for the running time, it would be the constant operation in the loop multiplied by the loop running n times. So what would be our time complexity? It would be big O of n. Is that clear, everyone? Please raise your hand if you have any doubts. Okay, so I'll continue. Similarly, for this loop, what would be the time complexity? Write the answer in the chat. Hello.
Sir, the time complexity of the while loop.
Yes. Inside the while loop, there is a constant operation. Yes. Big of the one. Big of n. Sorry. Yes. So yes, that's correct. Big of n. So let us now move on. We can find the time complexity of multiple loops by multiplying together the time complexity of each loop. This example, let us first look at the example. So for int I equal to 1 to n I plus plus, j equal to 1 to m j plus plus, and some constant code here. So we'll multiply the outer loop time with the inner loop time. So the outer loop runs big of n times, inner loop runs big of m times, and there are constant operations in the middle here. S- So our total time complexity will be big O of n into m. Similarly, let us now look at this example. It is the same as the previous one, but here instead of m we have n. So no, sorry, it is not, no, not this, not same as previous one. Here j runs from I to n, and I is from 1 to n. So what would be the time complexity here? So inside we have some constant operations. So let us analyze by taking different values of I. So for I is equal to 1, j would run from 1 to n. So it would run n times in a loop. For I equal to 2, it would start from j equal to 2 to j equal to n. So it would run n minus 1 times. Similarly, for each operation, if you similarly for each operation, we would have uh, n plus n minus 1 plus n minus 2 and so on. So our total time complexity would come out as n into n plus 1 by 2. As you've learned during your J time, this is the formula for sum of natural numbers till n. So would it can be written as n square. Since we can remove the smaller terms, so this can be written as n square plus n by 2. We can remove the simple multiplying factor of 1 by 2 and the plus n by 2 part. So it can be simply written as n square. Since we are concerned with how the graph will grow in shape as n grows larger and larger. So for this one, where I varies from 1 to n and j varies from I to n, it would be n square. Now, let us have a look at this one. Here I varies from 1 to n and j varies from 1 to n in the first nested loop, and in the second loop re varies from 1 to m. So here you can solve these separately for n square and m. As you know, inner loop runs n and outer runs n, so n square, and this one is m. So our total time will be n square plus m. Since this is different and this is different, so n square plus m is our total time big of so time complexity is big of n square plus m. If n square is much larger than m, we can neglect big of m and simply write it as big of n square. Similarly, if m is large, so n square would be much smaller, and so we can just neglect it and write it as big of m. So this would help us in analysis of different algorithms and data structures. Further on, let us now look at some more examples. So some of you might have seen this if you have started CP early. It is binary search. So initially left is we define a variable left as 0 and right is array size -1. So you can just think of it as n. So think of left is equal to 0 and right is equal to n. We perform some operation here, mid. If array of mid is equal to target, we have an array. Some of you might not be familiar with arrays, but I think most of you will be since it is part of basics. Arrays simply you have a long collection of collection of data which you can access by array square brackets and some number which would be less than its size. So it can be 0 to its size -1. So you have the left pointer at 0, right pointer at size -1. Mid is equal to left plus right by 2. So it's center of left and right. If array of mid is equal to target, we return it. Else array of mid less than target, uh, we put left is equal to mid plus 1, else right is equal to mid -1. So in this case, what's happening is in the first iteration, left is equal to 0, right is equal to n minus 1. So we have n elements to look for. In the second iteration, we cut half of it, assuming that we didn't find it in the first time. So we don't go there. So either our array element is less than target or greater than target. In that case, we'll cut half of it since our left is increased or right is decreased. So in that case, in second iteration, it would be think of it as n by 2 to n minus 1. So our size is decreased to n by 2. In third iteration, it will be halved again. And in kth iteration, it will be n to the power 2k. And it will stop when n to the power 2k is 1. So you can think of it as k iterations such that n divided by 2 to the power k is equal to 1. So the here is the equation for this. N to the power 2k is 1, and our time complexity here, since we run it for k iterations, so n divided by 2 to the power k is 1. We, we cross multiply it, put n equal to 2 to the power k, and then taking log both sides, we get k is equal to log log base to n. So time complexity will be equal to we go of log base to n. So if you don't get it, that's okay because we'll take a separate workshop for binary search later. It is one of the most used algorithms, especially in the beginners range. So we'll take a workshop on this later. This was just to introduce the log and time complexity. So now the exponential time complexity, or the 2 to the power n time complexity. Uh, let's So if suppose I have a set of n elements, what would be the total possible number of subsets? Write the answer in the chat. Right. So 2 to the power n. So if I give you the task of writing a program such that you take a set and list down all its subsets, all possible subsets. So that would be an example of a question that takes 2 to the power n time complexity. So you can think of it as that we are not including the code for that, since that would be a little bit advanced for you since you're beginners. Let us now look at space complexity. Space complexity is basically the same, similarly how you handle time complexity in big O notation, but here we are not riddled with time taken. Rather than that, we are riddled with the space taken by our data structures. So, for example, we've built arrays here of size n. So, two arrays, one has size n, the other has size n. Our space complexity will be big O of 2 into n, and we can also write it as big O of n simply, since we can remove the constant part in simple time and space complexity analysis. Here is an order for time and space complexity. So make sure you get this. Big of 1 will be less than log n, which should be less than square root n log n square, n cube, and so on up to n to the power 100, and then 2 to the power n. It is similar as how their graphs grow for very large n. For very large n, 1 is less than log n, is less than square root n, and so on. This would be important since, let me write down. Oh, wait, it is. So in 1 second, we can handle 10 to the power 7 to 10 to the power 8 operations. And on in general, during contests, CP contests, we would have constraints like 1 second or 2 seconds. So we should make sure that our number of operations does not exceed this value. So you can do this by uh, time complexity analysis. So suppose n is equal to 2 into 10 to the power 5. Is n log n feasible for me? Wait. So I'm giving a contest. There is a question in which n is equal to 2 into 10 to the power 5. Can I write my code where n is equal to this 2 into 10 to the power 5? First answer, can I write uh, n square? Will n square work given these restrictions and 1 second time? So I can only perform these number of operations, and n square, would it work? Yes, it wouldn't work. Why? Because n square would be equal to 4 into 10 to the power 10. So it would be equal to 4 into 10 to the power 10, which is greater than 10 to the power 8. So it would not work. Will n log n work? The answer is yes, because uh, n log n would work because log n at this value would not exceed 20 in for this value. So taking an upper bound, 2 into 10 to the power 5 into 20. So that would be equal to this, and it is still less than 10 to the power 8. So that implies that it would work. So this is how we will use this time complexity analysis in our programs, in our contest. So we could find out whether our code is feasible or not. So these are all a few questions for you. I hope you get the above questions. You can do this as homework. We'll provide you the link for this talk after the session ends. So let us now come to arrays. So if you want to see how a question of code forces looks like, you can just come here. So in general, a question looks like this. You look at the here's the name, here's the time limit, 1 second. You know it can process in 1 second 10 to the power 7 to 10 to the power 8. Here is the memory limit. In general, you'll have to worry about memory limit for a different level of questions, not for the beginners level, where you would use DP tables and all. So here you're given n for here n is equal to 1 to 100, and you'd be given input and you'll have to produce the corresponding output and output that, and you'll submit it here. So we'll come to that later. Let's come to arrays. A collection of variables of same data type. So it has fixed size or static size. Some of you have had a C programming course in your first sem, so you would be familiar with arrays since it was in C2. So it is simply a collection of variables of same data type. So AR, you can think of it as just zeros, 1, 2, 3, 6, and so on. But the problem is that you had to define the size early on. Suppose 4, and you can then make changes to it. So you had to define the size early on, and it cannot be changed. You can use malloc for some different operations, but mainly the size could not be changed. So in C++, we have vectors. Vectors are arrays with dynamic size, which is provided by the standard template library of C++. So they are defined differently than arrays, but you use them in a similar way, and you can change its size during your implementation. So there are different ways of declaring. For example, for in arrays we did data type, name, size, and if you wanted to define it early, you can just do it right here. Otherwise, you can do uh, ARR 0 equal to 7 after defining the array. For vectors, you will define it like this: vector data type name, so vector int of nums, or you can define it with a size. So think of it as vector int of nums size 4. Or if you want to copy an old vector's details into a new vector, you can do it. Vector data type new vector is equal to old vector. These are the names for, this is the name for new vector and this is the one for old vector. There are methods for accessing the element. For this one is similar to the one you did in C, where you just did v square brackets I. So it would return the value at the ith index, direct access. But we also have an alternative for here, v dot at I. The difference between dot at and I is square bracket I is that square bracket does not perform bound checking. So if you have a vector of size k and you did v of square bracket I k plus 7, it would not return an error, but it would return a garbage value. But for v dot at, it would return an error. So uh, for p dot at, it would return an error. In general, we just use the square brackets notation for accessing the ith element, not at. V dot front. V dot front is the method you use to access the first element of it. You can also just do v. You can also just do v of 0 to access the first element, but if you want to, you can use this, and v dot back is the one to access the last element of it. Okay, so let's look at some operations we can perform on the vector. Suppose we defined a vector of name vec, so we can perform the following operations on it. The first is dot pushback. So it appends a new element to the end of the vector and increasing its size by 1. And it has big of one time complexity. We learned about time complexity earlier. So we learned how to define vector of any size here. So if you want to declare a vector of size 3 with all elements set to 8, so you can do it by vector int name 3 comma 8. So size comma default value. And if you do pushback 22, the size would come out as 4 and will be equal to 4, and elements would be 8, 8, 8, and 22. It would add it to the back of the vector. Now, you can, what vec of I does is it accesses the element I of the vector. So if you do vec2 is equal to 99, it would modify the element at the 2 index. So 0th index, first index, and this is the second index. So it modifies the value at the second index to 99. Now, what pushback does is it modifies the vector, it adds a value 100 at the end of it. So this is the difference between the accessing one and the pushback one. So let's go to the second operation, which is resize. It changes the total number of elements in the vector. It changes the size of the vector. Syntax is simple: name dot resize new size, and you can also add dot default value to it. So vector resize 100, and if you want all the new elements to be 7, you can do it. And now let's look at sort. To sort the elements all in increasing order, we just do sort vec name dot begin and these parentheses. Don't forget the parentheses, otherwise you'll get error. And vec dot begin, vec dot end, semicolon. And the sorting takes n log n time complexity. It performs merge sort. Some of you will learn merge sort after in the second sem, and some of you will learn it later during your DSA preparations. Uh, so it performs merge sort, and you'll just have to write this code. It sorts it in the ascending order in the original array. This is the reverse operation. So write reverse vec dot begin vec dot end, and it simply reverses the order of all the elements in the array, a vector. So let's learn about iterators. So you see things like vec dot begin and vec dot end. So what exactly is dot begin and dot end? These are iterators. And iterator is an object like a point, which is like a pointer to access and traverse elements of any container, not just vector, any container. So for example, v dot begin, it returns an iterator to the pointing to the first element. So for example, we consider this array. I have an iterator to the first element. So it is not, if I do it is equal to v dot begin, it would not be equal to 2. It would be the pointer to that element, which is the memory address to that element. If you want 2, then you have to do star it, which is here. So what is auto? So we learned about data types like here, for example, int. We also have other data types like string and uh, like string or long and other data types. So what exactly auto does is there is a different data type for iterators, and it is often a very long one and long name for any container, and all the containers have slightly different names for this. So instead of writing that, we just write auto. For some of you, writing auto on your systems may give error since it is all often riddled with some errors with the compiler for some systems. So be careful when you use it. So here we are using auto it.begin. So it becomes the specific data types which is suitable for pointers. We can also access the array like this. Auto it is equal to v.begin, while it is not equal to v.end, it plus plus. Also, v.end is an iterator, returns an iterator pointing to the one position after the last element. It is not an valid element. It is used as a stopping condition. So if you have this array 2, 3, 99, 6, 9, v.begin is an iterator pointing to this element, and v.end is the iterator pointing to the memory address after this element. Not this element, but the memory address after this element. It is often considered a stopping point for several algorithms. So these were iterators. We will not need them much in vectors, but we'll need them in sets and maps, which we'll learn later in this session. So vector iteration techniques. You can either give a normal for loop, I equal to 0, I less than v dot size, c out to v of I. You can use auto xv, where v is the name of the vector and x is the name of the element in each iteration. If you add an if you add an ampersand here, it would modify values. Otherwise, it would be read only. In general, you would be using these ones. So let us now look at a problem. So given an integer array nums, return true if any value appears at least twice in the array, and false if every element is distinct. So assume 1 second time limit for this, and the length of the array would can vary from 1 to 10 to the power 5, and the value of integers vary from minus 10 to the power 9 to plus 10 to the power 9. So this is our n. In the worst case, it is 10 to the power 5. So how can we determine that all the elements are distinct? The elements can be in any random order. So you have to determine if all the elements are distinct or there is some value which is repeating. Share your thoughts in the chat. Yes, that is correct. Sort and then compare via loop. So here what we do is that we'll sort the array integer array nums and then vector nums. Since here in C++ implementation we are given an okay, we are given an we are given a function in which we are given a vector. So we'll first sort it. Let us look at it. So we'll sort the vector nums, and then from the second element, not I equal to 0, but rather than that I equal to 1, we'll check if I is equal to I minus 1, return true. And whenever we pass return, whenever the pass return, it just ends the function completely and returns the value true. And it does not run after that. So it would stop if any duplicates are present. Otherwise, we would simply return false. I hope that's clear. Do raise your hand if you have any query. So I'll move on to strings. So strings in C++, Strings are basically used to represent multiple characters. So, for example, int was to represent numbers, and strings are used to represent text like this. So, strings are used to represent and manipulate sequences of characters. They can automatically grow and shrink as you add or remove characters, unlike fixed C style strings. So, if you use strings in C, it was basically an array of characters, and just like arrays, it had a fixed size. Unlike the ones in C language, for C++, you can make strings of variable sizes. You can easily access characters, join strings, and compare them. Also extract substrings and search within strings using built-in functions. So let us look at some basic operations in string. First, initializing, just like how you do it for integers, data type, name, and value. So string str is equal to this. You can also initialize an empty string. If you don't want to initialize a value early, before that, so you can also initialize it like that. Also, accessing characters similar to arrays and vectors, you can do it using the square bracket operator or the add function. You can find out the length of the string using these functions, str.size or str.length. Both the accessing and the length operations can be done in big of one time. Concatenation of strings. So if you want to add two strings, for example, if you have hello and dots and the other string as the space comma juniors, and you want this string, so you can simply just do the add operation, and it would add the two strings, concatenate the two strings. So this takes big O of n plus big O of m time complexity, where n is the size of first string and m is the size of second string. So size of this is 5, and size of this is, we'll also add the space since it is also character. So 1, 2, 3, 4, 5, 6, 7, 8. So the total number of operations would be 5 plus 8, 13. Similarly, if you have a large string, suppose n is huge and m is equal to 1, time complexity would be order of n plus 1, which you can write as n also. Or you also have the append function, when you can use, hello, am I audible? Okay. So you can also use the append function. What this method does is you can write the final answer as str1. Suppose we want to write str1 plus str2. So result 2 is equal to str1 and result 2 dot append str2. So it adds str2 in the end of result 2. So you can do these two operations. First is concatenation, and second is the append operation to add two strings. There are other string functions, length and size. You have already seen them. Resize, it is similar to the one we studied in vectors, where you want to where you can resize the array, where you can resize the string here. Now we have clear. So what it does is it removes all the elements from the string and makes it an empty string. And we have swap. So what swap does is if you have string 1 and string 1 is hello, string 2 is space juniors. So you can use swap str1 comma str2, and it would perform this operation in big O of one time because it only exchanges the pointers, the iterators, not the actual values. So it is useful for the cases where you want to do this in linear time rather constant time rather than linear time. So that's the difference between swap or manually swapping the arrays. This is done in linear time. So pushback, it is the same as the one we studied in vectors. It adds a character to the end of the string. Pop back, it removes the character that is at the end of the string. Find is where you search for the first occurrence of a specified substring, and it returns the starting position. rfind is where you'd search for the substring and it returns the last occurrence of that substring. Sub str is where you pass the uh, indices of these indices of this string and it returns a substring. Compare is used to compare two strings lexicographically, returning as an integer. But you can all in C++, you can also compare strings like you compare integers. So you can do this. str1 is if str1 is less than str2, cout hello endl or something like that. You can do this rather than just writing this using this compare function. It works that way too. And it also does that lexicographically. So it compares the first character of both strings. If it is not the same, it will return the string one with the one with the smaller value, I think. You can double check this by just searching it on Geeks for Geeks or any other site. I prefer it. Replace is where it substitutes three elements in the raised first to last with uh, and that match an old value with a new value. So you you give the old value to it and give the new value to it, and it from the range it matches the old value and replaces it with a new one. Erase is where you give it a specific index or iterator for the for that element, and it removes the specific part of the string. Here are some other functions that are similar to the C style functions. These are the ones we don't generally use because there are better alternatives in C++. So you can study these ones if you like to. We'll move on. GetLine function. So what cin does is that it stops whenever it encounters the first white space. White space is any space, tab, new line, or similar space blank character. So what cin does is it stops at any white space character. So if you have input hello world and you do cns and then couts. Wait, we'll also define it. So if you have hello world as the input and you do string of s, cns, cout s, it would just cout hello rather than entire hello world because it stops at the white space character. What getLine scene comma s does is that you do string of s, you define it, You do get line seen as comma s and then see out as, and it outputs hello world entirely, the whole line rather than just hello. So in some cases, you will need to input the entire line rather than just a white space, rather than just the first word. So let's now have a look at overflow in C++. Overflow is something that occurs when a variable stores a value outside the range of its data type. So for example, you define int x is equal to some value. You know that x cannot store an infinitely large value. It has some ending point till which it can store, and after that it produces weird results if you perform operations on it. For example, if x, the range of int is 4 bytes, int uses 4 bytes to store the data, so the range is from this to this. This is minus 2 to the power 31 and this is 2 to the power 31 minus 1. So this is the max value that int can store. If you add, if you put x is equal to x plus 1, it would overflow and it would produce weird results. It would actually round off to this one. Adding 1 to this gives you this. This is a weird result that happens when you don't take care of the limits. So for in some cases, we'll have to store values bigger than 10 to the power 9. So for that, we use long int. It can store values from 9 to store values uh, as big as 9 into 10 to the power 18. So its overflow happens at this value. If you add 1 to this, you get weird results. So this is the maximum value you can store. For negative, it is the same. Just add minus in bit here. So this is why we take care of the limits, and you cannot use a value bigger than this or a value bigger than this when you use int or long int respectively. So am I clear till now? Raise your hands if you have any doubts. Okay, so I'll move on. Next topic we have is pairs. So we'll start in a minute. So pairs. A pair is a fundamental STL container designed to group exactly two values into a single unit. So you'll have a pair of two values, for example, coordinates x comma y, student data, roll number comma marks, time interval, which is start time, end time, or graph h. This is something you will study later, and some of you would be scared from this. So pair is very useful for containing two values together. They may be of different data types, and this is how you define it. It may look useless now, but why? as you do CP and you do more and more questions, you will find this more useful. So this is the syntax for this: pair type 1 comma type 2 name. So you can do it like pair int comma string p, which is equal to 12 comma Ankit. Also, you define pair in curly brackets whenever you do it. Same for vectors, you do it in curly brackets. You can also do it like this: auto name is equal to make pair val1 val2. So you don't have to write the data types in here. Like for here we have written int comma string, but here you just write make pair 12 comma Ankit, accessing elements. So if you want to access the first element, you write dot first, and if you want to access the second element, you can do dot second. And you don't add braces here, brackets here. So you don't do this, you just write p dot first. You don't add brackets. So age, for example, if you want to write age, age comma name, and then you want to access it. So int age is equal to p dot first, and string name is equal to p dot second. Some more some advanced usage of pairs are using pairs, a vector of pairs. This is something you will use a lot when you do CP, using vector of pairs and then sorting it ascending order, descending order, and so on. So pairs can contain other pairs, allowing for complex grouping. You can also do nested pairs. Suppose if you want to do XYZ coordinates. So X is your P1 dot first. Here it is pair of int comma int. So X is your P1 dot first. Y is P1 dot second dot first. And Z is P1 dot second dot second. So you have nested the pairs. It is a pair inside a pair. Now, pair comparisons. Pairs are compared lexicographically by default. So if you will have a vector of pairs and you'll sort it, then 2.5 will occur before 2.7. Since first it compares 2, if it is same, then it will compare the second element. So 5 is smaller than 7, then 2 comma 5 will occur before 2 comma 7. This behavior is useful for sorting. So how can you sort a vector of pair int comma int on the basis of second element rather than the first element? So you don't care about the second element. You just see if you don't care about the first element. You just see if the second element is smaller or larger, and you sort on the basis of that. So you want the vector to be sorted in the increasing order of the second element. So how would you do that? That you do that by using a custom comparator. So you will use the custom comparator a lot too. So first we construct a vector of pairs. So we constructed B. We push back elements in this 1 comma 40, 2 comma 10, 3 comma 30, 4 comma 20. So we'd want the order uh, 2 comma 10, 4 comma 20, 3 comma 30, and 1 comma 40. So you do sort v dot begin, v dot end, and compare by second, where this would be a function you will define earlier. Don't add the parentheses here. Although it is function, don't add this here. It is just a pointer to the function. You'll define the function earlier. The function must return a Boolean value. So either true or false. So you define the Boolean function earlier. What this Boolean function does is it takes pair one and pair two. So in our case, in this whatever. So what custom comparator actually does is you take element one in element two. I'm not just saying this for vector of pairs, but you will use custom comparators for different types of data structures. not just vector of pairs. You can also use this for vector of int, vector of int, and many others. So how will you do sort it on the basis of second element? So we will look for the second element first and then the first element. So if you are returning true, basically you are telling your wait, let me give an example first. So if you want to sort an vector of pairs and you get these two elements, which one should occur earlier and which one should occur later? We want the vector of pair of int comma int to be sorted according to the second element, and if the second element is equal, then sort it based on the first element in that case. So which element should occur first? This one or this one? Write in the chat. 2 comma 10 or 4 comma 40? Yes, 2 comma 10 should occur earlier. So what this custom comparator does is, if the first element if you want the first element to occur earlier, you would return true, otherwise you would return false. So suppose here a is equal to 4 comma 40 and b is equal to 2 comma 20, and we want b to be first, b to occur earlier, we would return false. So their order gets swapped. Otherwise, we'll return true. So this is how you write the custom comparator. So here, if a dot second is less than b dot second, return true. If a dot second is greater than b dot second, return false. And if they are equal, so we have done for these two cases. Now only remains the one that remains is the uh, case where they are equal. So this is a comment, by the way. So if a dot first is less than b dot first, return true, and otherwise return false. So this is how you write the custom comparator, and it would sort it in the order 2 comma 10, 4 comma 20, 3 comma 30, and 1 comma 40. So after that you output the string, you output like that, and then it would be sorted in that order, the one you want. So this was pairs. Any doubt in this? Because this would be important for a journey. So you guys wait just a minute.
Hello, hello, hello. Hello, guys. Am I audible? Okay, guys. I will be continuing from set. And I hope everyone is comfortable in Hindi also. I will explain in English and Hindi both. So don't be afraid if you are not comfortable in Hindi. I will explain in English also. Okay. I hope everybody is clear. Okay, so I will be starting from set. So set is basically a container that stores element based on three properties. So yeah, you can think as set that basically stores unique elements in sorted order. Okay. Uh, so basically, this is a set. It will store elements uh, in sorted order, and all elements are unique. Uh, Okay, so I will be going for the declaration part. How we are going to declare it? We can declare set in this manner. Set int whatever you want the data type as. Int represents integer. K represents characters. Or if you want to declare pair intent, then you can also declare it here, like set pair intent. Okay, so I will be basically going for int, set int, then define your variable name. That is basically I am defining st. Okay, so basically declaration part is set int s, set string names, basically for string, set pair intent. Okay, so set will store unique values in sorted order. Now the interesting part is if we want to insert the element or delete or such, then the time complexity is order of log n time. Okay. Basically, if you are storing the elements in vector, then these are not stored in the sorted order, and the time complexity of searching the element will be order of n. But in set, the time complexity will be order of log n. Okay. But if suppose you want to store the elements in the descending order instead of in ascending order, then you could just have to put this comparative that is basically greater int. So what will it do? It will store the elements in descending order. Okay, and basically set is also implemented using a balanced binary search tree that you will read about it later. Okay, I hope everyone's clear about this. Okay, so basically how to insert the element in the set, you just have to write as basically our variable name, that is st dot insert, and whatever value you have to insert in it. Suppose I have to insert 10, then I will write s dot insert 10. Let's fill up some more values. St dot insert 1 st dot insert 10 again. Okay, so now I inserted 10, I inserted 11, and I inserted 10 again. So what will set store in its container? So if I output the set values, then it will output only 10 and 11 as it contains unique elements. Okay. So insertion part is done. Now how to iterate over the set? So there are basically two methods to iterate over a set. First is for to it is to अपना वेरिएबल नेम जो भी आपका st है. So it will iterate over a set in ascending order. So if we print cout it, then it will output 10 and 11. This is our first method, and I prefer mostly this method to iterate over a set. The second method is of by using the iterators. So if we define for auto it equals to st dot begin. Okay, so st dot begin points the initial value of a set. That is basically if we are pushing 10, 11, 12, 13, then the iterator points to 10th value of a set. Okay, and the st dot end points points to the just next value of a set. That is basically 10, 11, 12, 13. Then the last value is 13. It will point just 4 bytes ahead of the 14th value. So if we want to access the last value, then it will basically say st dot end -1. Okay. So I will iterate my loop from st dot begin and it is less than st dot end and it plus plus. Okay. Okay, and you can output your value of basically it by doing a star it. It will reference the value. I hope everyone knows. Okay, now what set gives you? It gives you a searching function. If you want to search that if the given value is present in a set or not, then a find it function will help you. So basically, we have a set 10, 11, and only we have a set that consists of 10 and 11 value. If I write st.find 10, then it will return the pointer which will point to our given value. If it is present in a set, then it will give the pointer that points to 10. If the value 10 is not present in a set, then it will return st.end, basically the ending point of a value, right? So basically we want to find that if some value is present in a set, then what we can do auto it equals to st.find 10. So basically what will it return? It will return the iterator which points to 10, or so what we can write is if it is not equals to st.end. So basically, if it is not equals to the ending part as st.end, then we know that the it is present in a loop in a set basically. So we can write cout found. Else we know it is not present, cout not found. Okay, same is written here. Mm, then the deletion part is comes. How to delete? We can directly delete our value by accessing the value that is s dot erase 5. If 5 is present in a set, that can easily be deleted. Or what we can do is uh, we can find the iterator that is pointing to our value, and then we put our iterator 8 in our erase function. So it will erase that particular value. So let's say we have a set. Set that contains 1, 2, 3, 4, 5, basically 6. So here 5 is present in a set, so it will remove the erase the 5 value from our set S. Or we can what we can do is auto is equal to s dot find. We know that it returns the pointer that points to our value. Okay, so if it is not equals to s dot n means it is if it is present or not, it is present in a set, then we can say s dot erase it, right? And let's suppose we have to clear our set to make it empty, s equals to empty. So how we can do? We can directly do is that s dot clear. Okay, guys. Okay, so let me discuss the time complexity of this. First, set stores the value in ascending order, in sorted order, and unique values were present. So the time complexity of insertion will be order of log n. Iteration will also be order of log n. Searching will also be order of log n. For deletion and basically all the functions that set is providing you, the time complexity will be order of log n. Okay, is that clear? Hello. Is it clear, guys? Hello. For deletion also, the time complexity will be order of log n. Okay. Mm, This is an important note that while iterating over your set, please do not try to remove the values in the set. Basically, it will give you error. Okay. Now we have two functions. First is lower bound and second is upper bound. So basically, what does lower bound functions do? It returns an iterator to the first element that is greater or equals to x. So basically, suppose I will write it here. Suppose your set is s equals to 1, 2, 3, 4, 5. And if I write s dot lower bound 4, then it will return as an iterator for the value that is just greater or equal to 4. Now we know 4 is present in a loop in a set, then it will return the iterator that points to 4. Suppose 4 is not present in a set, then it will return the value that is just greater than 4. Basically, it will return an iterator that points to 5. Okay. And there is another function that is upper bound. So what basically upper bound functions do? It will return an iterator for the first element that is just greater than x. Suppose 1, 2, 3, 4, 5 again. Then we know 4 is present in a loop in a set, but it will return an iterator that is just greater than x. So if we write s dot upper bound 4, then the value that is just greater than 4 is 5. So it will return an iterator that points to the value 5. Okay. And again, the time complexity will be order of log n. Okay. So basically, let's suppose we have a set s equals to 1, 2, 3. And I write s dot upper bound 3. So according to you, what will be the answer? Set is 1, 2, 3. And I'm asking s dot upper bound 3. Then what will it return? Anyone has any idea? Okay, guessing. Pratik, you are right. It will return the iterator s dot end. Basically, there is no value found in a set that is greater than 3. So it will directly return s dot end. Okay. So what does it mean? That there is no value present in a set that is greater than 3. Hmm. Pratik, you are right. Okay, the time complexity I have already discussed, or order of log n. Okay, there are more things related to set. Suppose you don't want the order of the elements to be sorted. You just want to store unique elements in your set. Then there is unordered set for this. And you will be surprised to know that the time complexity for all the functions that we have discussed for set will be reduced by order of 1. So basically, what does it mean? If you don't want your elements to be sorted in order, then time complexity of find function, mm, insert, lower bound, upper bound, and yes, that's it. So the time complexity will be order of 1 in general cases. And let me tell you that you can consider that this will always be used order of 1. In some cases, it may go up to order of n. So basically, unordered set uses hash table to store the elements. So if there is multiple hashing occurring in a set, then it can go up to order of n. But in general cases, or the average time complexity of find function, insert function is order of 1. Okay. So you can access the element, you can insert, you can delete, you can search the element in order of 1 time. But it may go up to order of n in extreme cases. Then, okay. One thing is, okay, you have a set. Set stores elements in unique order also. Means unique values will be present in a set. If you don't want that unique values should be present in a set, then you can use multi-set. all the functions are same for another set and multi-set also. So what basically multi-set will do? Multi-set will store elements in sorted order, but not unique. The declaration is simple, multi-set int where whatever the data type you want, and basically I am writing m. So m dot insert 1, m dot insert 1, m dot insert 2. So a multi-set will look like m equals to 1, 1, 2. So you can say here the values are not unique. Multiple values can be present. So if you do not want your values to be unique, you can use multi-set instead. And the time complexity will still be the same as said. For find function, it will be order of log n. And basically for all the functions that we are using, the time complexity will be order of log n. Okay. Mm. Okay, here is a one question. I hope everyone is able to see it. So what does this question says? Given a list of integers, we have a list of integers and we have to write a C++ program to remove duplicate elements and print the remaining elements in sorted order. Okay, so one can say that we can store it in a vector and then sort our given vector, and then we can remove the duplicate elements also. So the time complexity will be same, but it will be complex to us to remove duplicate values and to sort our given vector. Okay, so instead what we can use here, we can use set here. So what will it help? It will help to remove duplicate elements and also to store the elements in sorted order. And obviously we all know that how we are going to access it for auto8 st cout it. So this question can be done using set. Suppose here instead I do not want to remove duplicate elements. So what I can use? I can use multi-set here. Okay. So basically input is n equals to 7, 4, 2, 4, 1, 2, 5, 1. Output will be 1, 2, 4, 4, 5, and we all know this can be done using set. Okay. I hope everyone is clear. Guys, can I move forward to map? If anyone is having any doubt in set, he or she can ask. Okay, guessing no one has any doubt. So I will be discussing map now. Okay, let me give you just one idea. You know set, and there is no indexing present in a set, right? Like you can't access st of 2. So it will return you the second value present in a set. So I'm just giving you the idea. If you want to learn, you can search it in ChatGPT or any other, and we will discuss it later also. So there is one thing present that is order set. For this, we have to include some other libraries also to include this thing. That is basically order set int st. So here we have the power of indexing the elements. Now we can access st of 0, st of 1, right? And also it provides some additional functions that will help you to solve some particular questions. Okay, I'm just telling you, we will discuss it later also, but I'm just giving you a short idea about it. The time complexity will be same order of log n. Like if you see many questions were directly asked which can be solved using the order set. So if you want to learn, you can search it in ChatGPT. It will give you all the functions related to it. Okay, now going for map. So map is also a STL container that stores element in the form of pair. So basically, map stores value in the form of key and value, where our key is unique and different keys can uh, point to same value, right? So it is basically a container. Suppose we have a vector array, vector of char, mm, A, B, C, D, right? And someone asks us to output the number of elements or output the number of counts of each character present in a given vector. So we can solve it using map. So what will map basically do? I will tell you the declaration first. We can declare map by map int, int, and mp. Okay. So here what is the first value is doing? It is basically a key. It is the data type of a key. Here the data type of a key is char. So we can write here char. And we want the count. So basically the count of our values will be int, right? So basically we are forming a map of char comma int and mp. Now, if we want to insert the values in it, then there are two types, two ways to insert the values. First is mp.insert. Then you use curly braces for inserting the pair values, right? So mp.insert, suppose we have a comma, its count is 2. So we can insert like this. And suppose we have to insert mod values, mp.insert b comma 1, mp.insert a comma 1. Okay, so here the important thing to notice here is we are inserting a with the value of 2. So a is our key and 2 is our value, right? So it will insert the in our map, the key is as 2 and the value is 2, right? Then it will insert the value b and 1. Now again we are inserting k, and we know that in map the values keys are unique. So it will just ignore this. It will not update the value as 1. It will just directly ignore this. Okay. So if I am going to print our map, it will show the values A as 2 and B as 1. Okay. It will ignore this part as it is already present in our map. Now, if we the another way of declaration of inserting the values is basically mp of, here you will write your key, that is basically I am writing A, right? And here it is a value, whatever value you have to write. Now, in this part, if you are accessing the same value again, right? I have, let's suppose I have a map of int comma in mp, and I want to write mp of 1 equals to 2, mp of 2 equals to 3, mp of 3 equals to 4. Okay. So here what will happen is, ignore this capital letter, it will be written in the mp form also as it is. mp of 1 will declare our key as 1 and its value is 2. mp of 2 will declare our key as 2 and value is 3. Now, we are accessing again 2. So now it will not ignore this value. It will update the value of 2 as 4. Okay. Here also, this is the insertion part, and if the key is present, it will ignore it insertion. And meta 2 is directly accessing the values, and it will update the value that is present in our map. Okay, so one thing also let me tell you, if you are not giving any value and you are just declaring it as this mp of 3, I'm not giving it any value. So the C++ language or the map will give a default value to it. And what is the default value in this case? Default value will be 0 if value data type is int or long. In case of string, default value will be empty string. Okay, and you can access this later also. Now again for iteration also, it is same as sets, but here you know that map stores the value as pair. First is key and the second is value. So we have already discussed pairs. So you know how to use pair for auto it or basically entry, and we are iterating over our map. Here is it as our map name. So it is basically a pair. So how we are going to access the values? The key value will be accessed by using it dot first, basically entry dot first or basically whatever. Here it is. Let me tell you. It is entry dot first and it is entry dot second. Okay, and the second method is basically the iterator method that we have discussed in set also. We are here also it dot begin points to the first element in the map, and it dot end basically the ending part. For auto it takes to basically the first value, and जब तक वो एंड के बराबर नहीं होता तब तक हम अपने काउंट को 8 प्लस प्लस कर रहे हैं. And there is basically one difference. If you see here, we are accessing our pair values. It dot first, here it is dot, and here it is arrow. It is because it will directly points our pair, so we can access it with dot. So basically, it dot first or it dot second, but here it is a pointer. So when we are accessing values through a pointer in pair, then we can't use dot to access the value. We will have to use arrow. So this is basically the arrow that points to the first, and first is basically our key, so it will give you key, and the arrow second will give you the value of that key. Okay, now important functions in set also you have a size function also, and the time complexity of the size function is order of 1. Okay, both in set and map, the time complexity will be order of 1 for size function. And basically for insertion also the time complexity will be order of log n. Insertion erase function is basically you can give the key value and it will directly erase that part. Or what we can do similar to as set, we can call our find function to find that particular value. That is basically our map name dot find and whatever the value key value is. And if it exists, then if it exists, then it will return the pointer to it, and if doesn't exist, then it will return directly end pointer. So if end pointer comes, then we can say not found, and if it is present, then we can use our it dot erase function uh, and put our iterator in this, so it will remove the value. The time complexity will be same as set, that is basically order of log n. Log n for insertion, deletion, find. Order of 1 for size. Now here again, we know in set, if we don't want the order to be in sorted order, then we use unordered set. Similarly here, unordered map is there. That will store the value in unordered manner. And the time complexity is same as unordered set, that is basically order of 1 in most of the cases. But in some cases where collision occur, TC will be order of n. So I will recommend you to use ordered map and or map and set instead of unordered map, because in some cases you may find that the time complexity of accessing will be order of n, which will give you TLE in most of the NCP questions. So I will prefer you to use set and map instead of unordered set map. Okay, as the time complexity of order of log n, and in most of the CP questions, log n factor can run in a code. This is basically what I am telling you. Unordered map. When ordering doesn't matter, it's better to use unordered map because it is much faster in computation. Basically, order of one. But map uses red black tree, basically a type of tree. And for this, the time complexity of accessing, finding, deletion will be order of log n. But in unordered map uses hash table. So generally order of one, and in some cases it will go up to order of n. Right. Declaration is like this: unordered map. Here is your key data type, and here is a value data type, and whatever name you have to give to your map. Rest everything remains same as map. Now, here one problem we are discussing. It is cheat code problem. I will put the link in chat also. So if anyone has to enter, he or she can open this. Okay, code is already written. I've already solved this. Okay, so it is an easy question of cheat code. The famous problem, twosome. So what problem says we are given with an array of integer nums and an integer target. Return indices of the two numbers such that they add up to target. Okay, so it is a basically problem. We are given with an array of integer nums and we have a target, and we have to return two indices such that the sum of the value present in these indices adds up to our given target. Okay, so how we can approach this problem? The first brute or nav approach that may come in your mind is basically we can iterate over for int I0, I less than n minus 1, I plus plus. And from I plus 1, we will go up to n. And if our value, if v of I plus v of j equals to target, return ij. Right. So this is basically the brute approach or the nav approach that we are discussing here. If you see what we are basically doing, we are fixing one value, basically one index. Let's suppose this index is I equals to 0. Then we will iterate over all other values then I. So if 0, then we will iterate over 1, 2, 3, 4 up to n. And if check that if the value presented I plus value presented or j is equals to target, then we will return that index. Okay, so this is basically brute approach. And time complexity will be, we have already discussed in the time complexity part. This loop will run n minus 1 times, and this loop will run from I plus 1 to n. So basically it will be time complexity of order n square. So if our n is 1e5, 1e5 is basically representation of 1 into 10 to the power 5. Okay, then of n square will be 2 slope, and it will give TLE. TL is basically time limit exceeded. So instead of our brute approach, what we can do is we can declare our map with int comma int mp, and we will iterate over our given array. Okay, so what we will do, we will fix this value, that is basically the value present at the index I, and we know the remaining value to find is target minus the value presented ith index, and we have a map. So basically what we will do, we will, okay, I have not discussed one function in map. So there is another function in map that is basically mp.count, and here you will write key. This will return either 1 or 0. If the value is present, if that particular value is present in our map, then it will return 1. Or if that particular value is not present in a map, then it will return 0. Obviously, the time complexity will be order of log n again. Okay, so mp.count is basically, you can say auto8 equals to mp.find that particular key. And if it is not equals to mp.end, then you know that this particular value is present in a map. So it will replace this whole part as this single line mp.count key. Key is basically the value that we have to find in a given map. Okay, so it will return either 1 or 0. If it is present, then it will return 1 and as 0. And the time complexity is order of log n. So what we can do, we can check in a map mp.count that if that particular value that is remaining is present. Okay. If it is present, then what we can do, we can return the indices I comma that particular value that we are going to access mp of remaining. Else, suppose that particular value is not present, then what we will do, we don't need to do anything, we will just push that ith value in our map with the index is equals to I. Okay, so this is our code for this. And if we discuss the time complexity also, the time complexity for this will be order of n into log n. Why? N factor for loop, and in each iteration we are calling count function that contributes extra log n factor. So our final TC will be order of n into log n, and we know that n log n is much more smaller than n square, so it does not give TLE. I hope everyone is clear with this question. If anyone is having any doubt, then he or she can ask. Is it clear? Guys, do respond. Okay, I guess everyone is clear. If someone is having any doubt, then he or she can ask. Okay, I guess no one is having any doubt in this question. Then I can move forward. Okay, so this is basically the end of our session. We have discussed mm, time complexity, big O notation, then login time complexities, space complexity, then arrays, vectors, and all the functions that we use in vector. After this, we have discussed strings, then overflow part in the C++, then pairs, sets, map, and another map. Guys, we will be taking next session soon, and this will cover prefix array topic and number theory topic. So we are giving you this doc link, and I hope everyone read this doc. And prefix array part will be homework for you. You will read it, and we will discuss it in the next section. I hope everyone is clear. If anyone is having any doubt in any topic that we have discussed till now, then he can ask.
Also, if you guys have any doubt regarding the club recruitment process, you can ask doubts about that too.
Guys, you can ask if you are having any doubt. You can ask in the chat also.
So recruitment will take place after maybe a couple of months. So uh, we'll also give a few one or two long contests and short contests to see your performance, and we'll also take a few workshops. We'll see your participation in workshops and the performance in contests and your general interest in CP.
गाइस अगर सीएफ पे अकाउंट नहीं बनाया अभी कोड फोर्सेस पे तो कोड फोर्सेस पे अकाउंट बना लेना हम लोग उस पे लॉन्ग कॉन्टेस्ट करवाएंगे अभी इन्हीं टॉपिक्स के एक एसटीएल और नंबर थ्योरी का जिसमें उसके क्वेश्चंस रहेंगे इट इज जस्ट अ प्रैक्टिस कॉन्टेस्ट कि तुम लोग उसे सीख लो और उसकी प्रैक्टिस हो जाए तुम्हारे लिए आज का सेशन कैसे लगा तुम लोगों को कोई डाउट वगैरह हो तो पूछ लो गाइस कोई डाउट हो पूछ लो।
डाउट नहीं है तो लीव कर सकते हो।
ओके भव्या, टू सम प्रॉब्लम है मैथ के, टू सम प्रॉब्लम, एक सेकंड स्क्रीन शेयर कर लेंगे। टू सम प्रॉब्लम में हमारा मैप स्टोर कर रहा है इंडेक्स ऑफ द वैल्यू की जो है हमारी मैप की, वो हो गई हमारी वैल्यू, दैट इज बेसिकली वी ऑफ आई, एंड द वैल्यू ऑफ वी ऑफ आई will store its index because we have to return the index of that particular value ना। ठीक है।